Hello everyone. In this video we're going to be taking a look at how we can use Ohm's Law and Kirchoffs laws, two very common forms of circuit law that allows us to take what appears to be a very limited amount of information and use it to actually analyze everything that we might measure in this circuit, and we could then go back and verify it using kind of TinkerCAD circuits. So let's start by looking at the actual circuit. Okay. So when we're in TinkerCAD and we start the simulation, if we rotate the resistor around, okay, or rather the potentiometer, at its lowest point, okay, it starts with a very high voltage. Okay, but as we start putting more resistance in, okay, we start limiting the ability of the circuit, both in terms of the voltage that's going through, specifically the potentiometer, as well as the amount of current that is happening too. Okay, and this is where we go back and kind of say, okay, well, what's this relationship? So for Ohm's law, okay, let's remember that we need to factor in that voltage equals current times resistance. Okay? That's going to be an important concept. And then Kirchoffs Voltage Law, at least how that applies to a series circuit, is if we take all of the voltages of the objects, so the voltage of the first potentiometer, the voltage of the second resistor in the circuit, it should add up to the total power supply that we have within this circuit. So one of the ways that I like to kind of approach this when I'm working on these problems is I'll actually set up a table, of V, I, R, and then I will identify each of the components that I know about. Okay, the resistor 1, resistor 2, resistor total, and then I may occasionally put in kind of a circuit analysis, the total circuit. We may not actually need that, but then we can start kind of filling in information that we do and do not know. Okay. So, for example, okay, if we say that the potentiometer is R1 and R2 is going to be that resistor, okay, we can take a closer look at the color coding on it, and seeing that it's brown, black, red, okay, that's actually a 1K resistor. Okay, so 1 kilo ohm. We can also pick apart the circuit. Okay, so in this case, I think we can actually kind of ignore the total part. We'll just consider it because we only see resistors in this one. Okay? The total voltage of this has to be equal to what the power supply is. That's what Kirchoffs Voltage Law tells us. So we know that we've got 5 volts. Okay? Knowing that we have a total 5 volt circuit and that the power supply is providing a 2.45 milliamp circuit, okay, that's starting to tell us a little bit about what we can kind of fill in. Okay. So, continuing forward, okay, we do know a little bit about resistor number 1, okay, the potentiometer, and specifically we can see that the multimeter connected to it tells us that we have 2.55 volts. Okay. That's all getting a little tightly packed, but we're going to start having some formulas popping up in a moment. Okay. So from here we have multiple options about what we can kind of fill in and start using math to enter in the unknown portions. Okay. So at this particular moment, okay, we can actually recognize 2 parts. Okay? we can see what's going on with resistor number 2 and its voltage. We could also use Ohm's Law to figure out what is the total resistance of the circuit. Okay. Now, I'm feeling a little basic, in terms of this calculation, but I'm going to go ahead and solve for the voltage of resistor number 2. I think that's going to be a little easier because that's basic addition and subtraction. Okay. We know that with Kirchoffs Law, V total is equal to V1 plus V2. In this case, the voltage total is 5 volts, and that's going to be the voltage 1, the voltage of resistor number 1, which is 2.55 volts, plus whatever V2 is. Well, we rearrange our formula. 5 volts minus 2.55 volts equals V2, or we can simply say that 2.45 volts is going to be equal to V2. Okay. And we're able to go ahead and decipher a little bit more information. Okay. Now, another thing to kind of consider is that our current has to be equal. Okay. We kind of skipped that part when we were analyzing our circuit, but it's important to remember that in a series circuit, current stays the same. Whatever force the electrons being pushed through the first resistor, the first LED, it's going to be the same as it pushes through every single other component in that series circuit. So we know that 2.5, or sorry, let's erase that. 2.45, and we're dealing with milliamps. Okay. We also know that that's going to be true for the top. Okay. So here's where we can verify our math. Okay. At the moment, we're kind of assuming, okay, that these two are going to be true values. Now, we also know that that 1K resistor is what we expect. Like, we literally measured that. Okay? So this is where we can use math to check our values and make sure that we're on the right track. Okay? So, going back to drawing a little bit, we'll change the colors for this one. Do maybe red, we'll say. And we're basically using Ohm's Law, V equals I times R, to figure out if we're using the right numbers. So in this case, 2.45 volts equals 2.45 milliamps times 1 kiloohm, okay, or 1,000 ohms. Now, important thing to remember about Ohm's Law is Ohm's Law only works if all of your units are in their base value. So for us, that means that we need to do a little bit of unit conversions. But nice thing about the metric system, it's all powers of 10. So we do not need to change the 2.45 volts, but we do need to change 2.45 milliamps to amps. That means that we're moving that decimal point 3 points to the left. So that is 0.00245 amps times 1,000 ohms. Okay. And when we actually run the numbers, well, it kind of cancels it out. Okay. And we should end up with 2.45 volts equals 0.00, well, sorry, erase that for a moment. we know that we can go ahead and take that 1000 times 0.00245, and basically we're putting it back into 2.45, and amps times ohms is a little awkward, but when we consider the unit conversions going on, we're still getting the right value. Okay, so this is actually checking out. It's verifying what we needed to know. Okay? So, with that said, okay, we know that the current's right, we know that that first voltage is right. What's left is we need to figure out two things. First, we need to make sure that we're recognizing what the total resistance of the circuit is. And then we need to piece that together to figure out what is that R1 value. Okay? So, let me go ahead and clear out some of our calculations. Okay? What's next, okay, is we can kind of take our pick of which one we want to go for. Okay? I think we might be a little bit better off using Ohm's Law to go ahead and figure out what is that R1 value. Okay? So 2.55 volts equals 2.45 milliamps times the resistance of R1. Okay? Again, we rearrange our equations a little bit. Okay? 2.55 volts divided by, since we need to divide by both sides, 2.45 milliamps equals R1. We need to convert milliamps to a base unit. So 2.55 volts divided by 0.00245 milliamps equals R1. At which point we can break out our calculator and basically say 2.55 divided by 0.00245 equals, okay, and that tells us, in theory, that resistor 1, let's see, so gotta make sure I'm drawing this right. Resistor 1 should equal 1040 ohms. Okay? So pretty similar, but not quite the same as resistor number 2. So to verify this, okay, using using just what we know about combining resistors together, okay, so our total is usually going to be R1 plus R2, continuing on. Okay, we're going to expect our total, okay, to be equal to 2040 ohms. Okay. To verify that, okay, again, we like verifying information when we can. Okay. We're going to apply the same concept to what we know about the total circuit. Okay. So knowing that our total is that 5 volts equaling 2.45 milliamps, okay, times our total, we can again break it down and go through those steps. 5 volts divided by 0.00245 milliamps equals our total, which means, breaking out the calculator once again, 5 divided by 0.00245 equals that same 2400 ohms that we were looking for. Okay? So our total equals, again, 2040. Okay. So again, a lot of mathematical calculations that are going through here, but we've been able to verify our numbers and use it to figure out what the circuit is.